Every single month, developers and entrepreneurs throw money at cloud AI subscriptions just to hit rate limits, deal with server downtime, and watch their proprietary data leak into corporate training pools. Stop paying the cloud tax. Today, we are breaking the cloud dependency circle. I'm going to show you how to drop your AI subscriptions completely and unlock an unlimited local first setup. Your entire data stays on your device, meaning 100% absolute privacy, and you get the full generative capability of frontier intelligence without spending a single dime. We'll also be installing Ollama, the definitive engine that makes running local AI as simple as executing an app installer. Let's get to it. Before we push the button, let's audit our hardware fortress. So, local AI relies heavily on two elements, your system memory and your graphics card. While a basic 16GB machine can run standard models comfortably, a high-performance workstation utilizing 48GB to 68GB of RAM combined with a dedicated GPU like an NVIDIA Quadro RTX 4000 represents the absolute sweet spot for zero latency execution. But here is the real value milestone: outcome over tool. Even if you are running on an older or hardware-constrained computer, you are not locked out of this revolution. You can pull lightweight, highly compressed tiny models like Qwen 2.5, 1.5 billion parameter with absolute zero lag. Optimization beats expensive hardware every single time. Now, without any further ado, let's dive into our Ollama installation. So we'll visit the official Ollama website. Now, installing Ollama is completely seamless across Windows, Mac, and Linux platforms. So we'll hit the download button. For Windows, it's a simple executable wrapper. For Mac, it's a standard application drop. And for Linux, it's a one raw, one-liner shell core script. I've prepared a free installation guide and necessary resources. You can find the download link in this video description. Now, I'll proceed with downloading for Windows as it matches my operating system. And take note, this requires Windows 10 or later. And right here, I have my download ongoing. Upon download completion, I'll verify to see we are running a fresh install. Now I'll access my command prompt and run as admin. Right here, run as admin or run as administrator. So I'll verify the Ollama version to see if we have Ollama installed to make sure we'll be running a fresh installation. So this is how you check your current Ollama version. It shows Ollama is not recognized as an internal or external command, operable program or bash file. And now we'll proceed to run our Ollama installation. Now back to my browser, I'll launch the setup. The setup is about 2GB. So we'll proceed to click on install. And here we have the setup running. And just like that, our setup installation is completed. Now, we'll go back to the terminal to verify our installation is successful, and we check the current version we have running in our operating system. Now, I'll close the command prompt and relaunch again. And there we have it. It shows Ollama version is 0.24.0. Our Ollama is successfully installed. Now, pay close attention to this next part. We'll be making a pro-level adjustment. So, by default, Ollama stores massive AI weights straight into your primary boot partition like your drive C. If your drive C is small or cluttered, your system performance will degrade significantly. We are bypassing this constraint by injecting an explicit environment variable, which is Ollama models. So we'll be pointing straight to a secondary high-performance SSD directory. This step guarantees your environment remains lean, fast, and unconstrained by storage limits. So to set this environment variable for Windows, here is the command. For Mac or Linux, this will be the setup. But have no worries, you don't have to necessarily memorize this. I've already inserted this quick configuration in the setup guide I mentioned earlier, so you can find the download link in this video description. This configuration is about pointing a different directory from your default drive C. So here, we are pointing the Ollama models we'll be downloading next up into a new location, which will be drive D Ollama models. Now, if you are not sure on how to point step by step to the exact folder you want these models to be downloaded into, let me show you a quick way. To find the exact directory you'll be pointing to, just locate the folder you want to install your models, like this. So I have this folder Ollama models created in my Drive D. So all you need to do to get the extension is you right click at the address bar and copy address. So once you copy the address, it will come with the entire extension you'll be needing. And you just have to replace it right here. So after copying the address, I'll just paste it in here. And there we have it. And if you are on Linux or Mac OS, you'll be doing the same thing, editing it like I just did with the Windows setup. So I'll copy the edited link and head to my PowerShell or command prompts and run it. So here I have my Windows PowerShell and I'll run as administrator. So it's basically similar to the command prompt I just used earlier, and I'll paste in the command. So just like that, we have set our environment variable for our models we'll be downloading next up. Now let's populate our local asset ecosystem with the exact open source model we'll be using for our local first project architecture. So instead of relying on generic cloud hosted endpoints, we are mapping distinct local brains to explicit outcomes. Now we'll launch our terminal and pull the heavy hitters. I'm giving a command Ollama pull Gemma 4 E4B. This model is Google DeepMind's state-of-the-art open model architecture, packing 4.5 billion effective parameters. It's natively optimized to bring enterprise-grade planning, vision integration, and sophisticated multi-step logic straight to your consumer laptop and workstation without a massive memory footprint. So its estimated size here is 9.6 gigabyte. Our download is 100% completed and is verifying the SHA-256 digest confirmation. And there we have it, success. Now we'll proceed to download the next model for our local first architecture. We'll be pulling Qwen 2.5 coder 7 billion parameters. Qwen is the vibe coding champion for raw syntax and execution we'll be using subsequently. And here we have the pulling request in progress. And we have the success confirmation. And next up, we'll pull DeepSeek 14B. This heavy-duty reasoning engine will come in handy for our autonomous OpenClaw fleet later on in this series. And this is good for troubleshooting and overseeing our entire process. And there we go. Upon DeepSeek download completion, let's confirm the models we currently have in our local first fortress. So I'll run a quick command. Ollama list. This lists all the models we currently have in our local asset repository. So the magic here is quantization. We purposely pull these optimized versions so they execute fluidly on consumer-grade hardware without forfeiting their deep programmatic awareness or core reasoning intelligence. So running the pull request like we just did, make sure to download the models into our local device. Now to run the model, we have to actually provide the run command. Let's quickly spin up a fresh engine instance using Gemma 4 E4B. Notice how fast the interactive terminal materializes. This isn't a slow API request routing across oceans and over-allocated server farm. This is a direct inference executing natively on your hardware, raw and unthrottled. Here is a quick tip. We'll start by setting the core persona, rules, and behavioral boundaries for the AI model. So I'm setting our system. I'm saying you are a senior alien tech developer specialized in local architecture. So think of this like giving the AI a specific job description before we start asking it questions so it stays in context. So in my test prompt, I'm saying I want to build an autonomous cargo status dashboard. Give me the database schema and a React component structure, and let's see what we get. So we can see the progress in real time. It works like magic. And just like that, we have the entire backend of a courier app or cargo shipping platform generated in seconds. And it doesn't end there. It gives us necessary tips and next steps to follow. Like here, it says, to ensure this system meets operational demands, remember these architectural imperatives. API gateway do not allow the React component to talk directly to the database. Event streaming. Given the nature of autonomous vehicles, the telemetry log should be ingested via an event streaming service like Kafka, and it goes further to provide some other details. And now it says output stream complete. Implementation protocols commencing. So we can proceed to the next step. I'll type /show info. This basically pulls the technical specs and metadata of the model we are currently using. Like we can see here, the model section, the architecture is Gemma 4, parameters, 8 billion parameters, context length. Here we have the quantization I just talked about for the kind of models we are using to make the most out of a consumer grade GPU. And also, if you ever want to see a full list of available commands right inside your Ollama terminal, you can type /? just like you see in the interface right here. We'll try that out real quick. And here we have the various commands we can use with Ollama. So we have the set to set session variables, we have show to show model information, load, and other commands we see right here. We can use clear to clear session context, and we can use by to exit. This by here is very important because after completing your session and closing this window, the Ollama will still be running in the background. So it is important to use /by so that it frees up those hardware resources for your next task. So Ollama doesn't just live inside your terminal window. It boots a background service running a native REST API at port 11434. REST API here means Representational State Transfer Application Programming Interface. Is a set of architectural rules that allows different software applications to communicate with each other over the internet. So real quick, we'll check on the localhost. So we have it here, localhost 11434. And here we have it, Ollama is running. And also in our taskbar, we can view to see that Ollama is also running. So this is the Ollama icon running in our taskbar tray right here. Now, let's quickly check out the capabilities of the models we have just installed. So I'll start by quickly checking on the available models. So I'll say Ollama run Qwen 2.5 Coda 7B. And now we can run a quick prompt. I'm saying, what can you do for me? And what are your capabilities? Let's see what we get. It says, as an AI developed by Alibaba Cloud, I'm here to help with a wide range of tasks. Here is what I can assist you with and some of my key capabilities. So it says question answering, language translation, writing assistance, learning and education, technical support, creative writing, summarization, programming help, recommendations, general advice, and all that. So it says my capabilities are constantly evolving as I learn from new data and user interactions. So feel free to ask me anything. Okay, that works. And let's go to the next. So I'll end this session. Bye. Next, let's check out DeepSeek. Next up, I'll ask the same question. What can you do for me? What are your capabilities? It says, as a general purpose AI, I can help you with answering various questions. I specialize in solving complex STEM problems through analytical thinking, especially mathematics, coding, and logical reasoning. And just from its response, you can see it fits the exact purpose why we are using DeepSeek 14 billion parameters in our workflow. And next up, we'll run the Gemma 4 billion parameters. And I'll ask it the same question. What can you do for me? What are your capabilities? We can see the other models just get to answering the question immediately. But the Gemma 4 is doing something different. It is starting by thinking, so it has a thinking process. It first of all analyzes the question it has been asked, then it figures out what the user actually needs before it proceeds to provide a suitable response. So it's showing identifying the user's request, establish core identity. It shows I must first state who I am, Gemma 4. And after completing its thought process, it is now providing a response. So this is particularly different with this particular model, unlike the two models we just tested. And we can see it's providing a quite comprehensive response to the question we just asked. So far it's showing knowledge and information processing, creative and writing assistance, including tone adjustment. Now it has logical and structural tasks, including coding assistance, brainstorming, input modalities, like how I understand you. So it's stating how it does to understand a user's input. So it does that via text input, image input, and it doesn't just end by saying its abilities. It also goes along to mention its limitations. So it shows what I cannot do, my limitations. It's equally important to know my limitations. So it says real-time actions, personal experience, real-time internet browsing, image generation. So it shows here I can process images and describe them, but I cannot generate images myself. That basically speaks for itself. We can see how robust this model is. And you can as well check my complete explainer video on the entire Gemma model by Google. In the video, you can see a complete breakdown and detailed explanation of which model suits what purpose for your personal, business, and everyday need. In the next video, we move from the terminal into the cockpit. We'll be turning VS Code into a custom high-performance AI lab that rivals GitHub Copilot, but for $0 a month. Do well to support our efforts with a like, subscribe, and I'll see you in the next video. Cheers!